Hello friends, welcome to my YouTube channel Phy-LAB Educate, and today we are about to discuss one another problem based on the topic work by energy and collisions, and especially based on ballistic pendulum. Friends, one of such problems we have already discussed in our previous videos. If you haven't seen up till now, I will request you to go and see the same and find its link in my description box, friends. In this video, here we are today, we are going to discuss a bullet over here of mass m moving a certain velocity u goes and strikes this wooden block of mass capital M and gets embedded into it, and then the two combine together and start moving as one system, and thereafter they start compressing this spring. So what we need to do, we need to obtain the initial velocity u of the bullet if the compression in the spring is given, or else you might also be asked to find out the compression in the spring experienced if the initial velocity is given. Friends, this is one of another classical numerical problem which is always asked at class 11th level. So friend, as I told you, there is a bullet of mass m. This bullet is of mass small m, and this bullet might be traveling with some initial velocity u, and then this bullet goes and strikes this wooden block of mass capital M, and then the both together moves as a single body system, and then they compresses the spring, something like this. As you can see, here is the bullet moving with some velocity u, strike the two together, and then they move as a block, as a single block system, and then they compresses the spring. So by what distance that the spring gets compressed, let's say x, that is the distance we are supposed to find out, where k happens to be the spring constant of the bullet. So k happens to be the spring constant of the spring. Sorry friend, spring constant of the spring. Okay, so this is a type of a numerical problem based on, once again, the ballistic pendulum, and we need to find out all these things, friends. Let's see how to go ahead with such type of problem. So friends, once again, this problem is based on two concepts. Concept number one, conservation of momentum. Conservation of momentum during collision. And it's very important for you all friends to understand that momentum remains conserved in any type of collision. Whether it's elastic collision, whether it's inelastic collision, the momentum will always remain conserved. Here, it's a case of inelastic collision. Why inelastic, friends? Because both the bodies stick together and move. So it's the case of inelastic collision, as both the body sticks together. Both bodies stick together and moves as a single system after collision, friends. So that's the reason why it's going to be referred by us as inelastic collision, isn't it, friends? So let's see this is the concept one which is going to be utilized in this problem. The second concept that generally is utilized over here is conservation of energy. After collision, friends. So during collision, friends, momentum remains conserved. After collision, energy is remaining conserved. Let's see what we are going to apply, how we are going to apply the conservation of momentum. So friends, when I am talking about conservation of momentum, so it says that momentum before collision must be equal to momentum after collision. So that's the first concept. Momentum before collision must remain equal to momentum after collision. Now, what is the momentum? What was the momentum before collision? So bullet was moving with mass, bullet of mass m was moving with initial velocity u. It's a vector quantity, so I put that vector sign, the top arrow, and the block initially was rest, so m into 0, and the both after collision moves as a single body system, so they combine together, the mass of the bullet and the mass of the block combine together, and then they start moving with a common velocity vc. C is here for the common velocity. So using this equation I can find the velocity, common velocity with which both the body, bullet and the block begins to move, and that happens to be given by this particular expression. So what you can do, friends, you can use this expression in order to obtain the common velocity. So let me write down this expression with equation number 1. Now what happens after the collision has taken place? The bullet and the block system begins to move with one common velocity. So the bullet and the block system now gain a kinetic energy. Now this kinetic energy is going to be lost in compressing the spring, and that gets converted into the potential energy of the spring. So according to the concept number 2, now the energy must remain conserved. So loss of kinetic energy of the bullet block system is going to get converted into gain in elastic potential energy of the spring. Now what is the loss of kinetic energy, friends? That happens to be half m plus m into vc square. And what is, where it is going, where it is getting utilized? It's being utilized in getting converted into the elastic potential energy. So what's the formula for the elastic potential energy? That is half k x square. What is k over here? K happens to be the spring constant of this spring. So this is a spring of a spring constant k. So let me write on here as k happens to be the spring constant of the spring, and x is the compression produced in the spring. So this half and this half goes off. So this equation can be restated as m plus capital M into vc square is equals to k times x square. Now friends, this happens to be my second expression which is going to be useful in solving this particular numerical problem. So with the help of these two, I can always solve a numerical problem based on such type of ballistic pendulum. Friends, do solve numerical problems given in your textbook. If not, you can always refer any of the physics textbook. These are the general classical numerical problems which you will find in most of the textbook, friends. Keep sharing the video with your friends so that they can also enhance the learning. Friends, thank you for watching. Don't forget to give a like or comment. अगर अभी तक आपने मेरे इस चैनल को सब्सक्राइब नहीं किया है तो प्लीज डू द सेम. Don't forget to hit the bell icon so that whenever a new video is loaded, you get the notification. Take care, and we will meet back again with a new video and a new solution. Thank you, friends.